Welcome to a lesson with Dr. Powell. Now, understanding what end behavior is, let's look at how to graph a polynomial that's factored. Suppose that we have something like this. F of x is equal to x minus 3 squared times x plus 1. Okay. We've talked about end behavior. Now let's look at local behavior. So close and far. We've talked about far. And now we're going to talk about close. But before we talk about close, let's see what the far would be in this case. Now this is in factored form. Would we have to multiply it all the way out to see what the leading term is? Not generally. But it's important to think about it that way a little bit. To get the leading term, you take the leading term of each factor and multiply them together. That's actually ultimately, after using distributive property, how you get the leading term. You just take the leading term of each factor, you multiply them together. In this particular case, it's x cubed, which means that the end behavior will be down, up. So we know that globally, or far away, we're going to start down and we're going to end up. And I just drew the x-axis. Okay. All right. So based upon that, now let's look at what happens nearby. Now the factored form will help us know what happens close up. In particular, I want to know where this graph hits the x-axis. Now the x-axis happens right exactly when the y value is equal to 0. So to figure out what x values the function crosses, what x values the function crosses the x-axis at, we simply just have the y value being 0 and we solve. So when something multiplied together equals 0, that means either this is 0 or that is 0. That's the only way to get it. If two things are non-zero, they can never multiply together to get 0. So at least one of them has to be 0. So if this one is 0, then x would be -1. So we end up getting one of our x-intercepts. That's called an x-intercept. So we get -1. Okay, now the other one will be at 3. Great. Now we're almost ready. The other thing we have to be familiar with is we realize that this right here, if you think about being close to -1, this is roughly going to be about a number. So close to some kind of number, but then you multiply it by this, it's going to look like kind of like a number times x plus 1. So kind of like a shift of y equals x in some case. And that's exactly what the graph is going to kind of look like right here. It's going to look like a straight line function with the slope here raised to the first power. Now, what about this one right here? This is going to look like a number times x minus 3 squared when you're close to 3. So it's going to look kind of like a shift of a parabola. So we'll keep that in mind. And notice this is a shift to the right. It hasn't gone up or down. So it's basically going to be on the axis. So we're going to get something that looks like this or this right there, kind of touching the axis. So when we hit the axis, we're going to expect to bounce. In fact, bouncing happens anytime that this power right here is even. So, but here, this is going to look like a straight line going through. Let's just start drawing. We know we start down somewhere here on the left. So we do it, and we know the graph is going to eventually hit this point. Now what happens? Well, we know it's like a straight line kind of up close, so we make it look kind of like a straight line as it goes through. Then we know at some point the graph's going to come back down to 3. What happens here? Well, we know it's going to look like a parabola kind of bouncing. So it bounces up, and then how does it end? Well, it just keeps going up. We've passed all the local points, the x-intercepts, and we're just going to keep going up to match the end behavior of from down to up. Notice how we used end behavior. We used it to know that we started down, and then we came up to the x-intercept -1. We went around, we bounced, and then we came up. Thanks for watching.